Hello and most welcome to Heidegger 1343, and today I will be talking about quantum creativity and how symmetry breaking is thinking. And I will be using facts, indications coming from Souparno Roy, but also the insight coming from Edward de Bono, who speaks about asymmetric thinking. And I will be looking into an article that I previously took up by Chris King, how the universe, life, evolves through symmetry breaking in the universe. And that symmetry breaking is, so to speak, foundational for what creativity and development / life is. So the foundation of the universe and what is the life force is the very breaking of symmetry. In some aspects you could say that classical physics is the opposite of life, creativity, direction and progression. It is, so to say, non-symmetry breaking, which usually means staticness, non-change. I will continue with the article by Souparno Roy, and I will have some references to develop the subject of symmetry breaking as the very foundation of life. I continue where I left off, which is page 4, second paragraph, mid-on. Keeping the above preface in mind, and also the free association theory of creativity, we separate the whole creative process in 3 distinct parts. One, picking up stage. The brain receives the external stimulus, which constitutes the first node in the creative process. From here, the mental state, represented by a vector in Hilbert space, will start its divergent evolution. This is equivalent to the situation where a creative person picks up his inspiration. The leap stage. The mental state, therefore, starts evolving in a steep or loose path to subsequent nodes by taking leaps between them. This is where the divergent thinking helps the node to make distant nodal connections. Expanding the creative process spatially and or temporally. Three, evolution stage. With continuous measurement of the evolution function, measurement here signifies the continuous bombardment of contextual inputs from memory and or the external stimulus. The evolution of the vector is encountered by a white noise under whose influence it exhibits non-linearity. And a chaotic nature. This is the face which separates two creative individuals. Say a musician and a painter. depending on the nature of the memory inputs and stimulus received. We will now go into an elaboration of the stages. First, the picking up stage. We start by using the standard method to explain any dynamical system and its evolution. That is, constructing a phase space. Phase space is a space which contains all possible states of a physical system. In this case, the physical system we are interested in can be represented by a mental state function. A wave function on the mental state space. Using Dirac notation, we denote this state function as psi or xi. Unlike the classical approach, where state of a system is denoted by a specific point in phase space. In the quantum mechanical approach, this is a complex valued wave function whose position and momentum cannot be determined simultaneously. Which, of course, is Heisenberg's uncertainty principle. The state function can evolve in time and can be changed by interactions with external stimulus or memory or experiences. Also, our constructed space is made up of all the probable states that this state function can achieve after these interactions. So to generalize, we can write Xi as a linear combination of all these probable states. Which serve as orthogonal basis of the Hilbert space of all mental states. Now, when an external stimulus interacts with a wave function, Xi changes to a different state from its initial state. Manusakis showed that this interaction happens via a concept known as operators. In quantum mechanical point of view, operators are the equivalent of observables in classical physics. So when the state function interacts with environment, a particular operator, say Q, operates on Xi and changes it to a new state, Xi1. This state transition depends on the structure and properties of Q. Manosakis used the example of binocular rivalry. And showed how the two possible state transitions are achieved. In our interpretation, the initial stimulus, which provokes the creative process, operates in the same manner, culminating in the new state Xi1. This Xi1 works as the first node of the creative network. Hence, change in the mental state function is what starts the creative process. This is the picking up stage. to leap stage. The transition state, Xi1, transits or jumps between conceptual nodes in this phase. According to the free association theory, the extent of creativity lies in the distant connections between conceptual nodes. Flatter the connection, the more divergent and novel it is. So, what makes these connections, which are spatially and or temporally separated, happen? To help visualize the reader, let's take the analogy of the structure of an atom. Electrons move in circular or elliptical paths, centering the nucleus. Each path is separated from the other via energy barriers. When the atomic structure is perturbed with an external agent, say a stream of photons. Electrons in lower energy states move to a higher energy shell, provided they receive sufficient energy to cross the barrier. Depending on the quanta of energy introduced, ground state electrons could reach any of the higher shells. Something similar we predict could be seen in case of divergent thinking as well. The state function Xi1, which constitutes the initial node, is previously acted upon by the external stimulus in the form of an operator. The stimulus, we believe, is the necessary perturbation that pushes the transition state Xi1 to leap to the next node. The probability of leaping to the next node is equally distributed amongst all the available unless there is an introduction of contextuality by memory or interaction with environment. But what is that energy? Similar to the atomic analogy, which is essential in this leap from primary to a secondary node. Now we get into the gist of it. Dependence on ambiguity. Here, ambiguity plays a very important role. We believe that the ambiguous nature of the external stimulus provides Xi the energy to leap to a secondary node. Similar phenomenon is quite common in the fields of nonlinear and quantum optics. Where transition or absorption rate of a particle is proportional to the intensity of the perturbing light. Likewise, in this case, the nodal transition rate is dependent on the ambiguous nature of the stimulus received. My comment there is how important that the stimulus is ambiguous, non-decided. Were it determined, the process would stop. Let us use an example to clarify the point. When a person hears a word, say tiger, which is absolutely unambiguous in nature. It is unlikely that the person would produce an unique or novel way of associating tiger with, say, suspension bridge, but a person having an ambiguous knowledge about both concepts has a better chance of associating them in a novel way. The third stage, chaotic evolution stage. The third and final phase of the creative process is chaotic evolution. Before starting this part, a brief overview of chaos theory is needed. It designates a specific class of dynamical behavior. According to Kellertz, it is the qualitative study of unstable aperiodic behavior in deterministic dynamical systems. The aperiodic reinforces the point that the same state is never repeated twice. Chaos theory has three essential properties. Firstly, they are very sensitive to initial conditions. Secondly, they can display a highly disordered behavior. And third, they are deterministic. That is, they obey some laws that completely describe the motion. So, where is the relevance of such a theory to our quantum leap interpretation? The phases we dealt with till now has a finite time limit set on them, namely tens or thousands of a fraction of a second. But what happens when we try to push the limit of time gradually higher? Also, what if instead of a single external perturbation, we had a continuous flow of stimulus to deal with. Also, what if each of these perturbations is analogous to performing a measurement on a quantum system? And each of the interactions with environment causes some irreducible effect on the system. Quite a few number of literature in the recent past has suggested that continuous measurements on a quantum system that is evolving with time is equivalent to averaging over all the possible trajectories that the particle might have taken. Also, this kind of measurements introduces some interesting conditions on the Wigner function of the quantum system. I will make a little summary so far, midway. In a previous lecture by Chris King, I went into how life, and for that sake, the universe itself, develops. That essentially all becoming is symmetry breaking. Material becoming as well as life evolves from a symmetry being broken. This article is going deeper even to show what we would call the mental node or the conscious node is also a quantum uncertainty state, meaning that its uncertainty is absolutely essential for the becoming of the world. we see here now a connection between consciousness and how consciousness is absolutely dependent on ambiguity. As soon as something is put into the open, defined or determined, the becoming process stops, because the conscious side is also a superposition. It depends on ambiguity. Ambiguity and symmetry breaking are the same thing, seen from different perspectives. And this also goes to show, as the other article I took up in 1339 about self-regulation, that there is an external system, so to speak, that regulates, that we are absolutely certain that ambiguity can come into us, so we can have perception. And I would expand that to call that a perceptive theory of ambiguity, that there can be no perception in the classical model. So this is, of course, rather a strong criticism of the classical system. It seems, according to Chris King and Souparno Roy, that life, no matter, can evolve with determinants, with definitions. Maybe there's a question?
Thank you, Hans. Since we are speaking about paper by Souparno Roy, and then we will soon go over to Chris King, I could make a pun on the name Roy. In French it would be pronounced like Roi, I think, like king. So we have two kings. But you wouldn't make any difference in French in pronunciation. Roi spelled with a iota and a y, Roy. And this is a difference, as Derrida would say, is that it leaves this in ambiguity. My point is that ambiguity is something good, as they point out, and I could repeat one sentence from here. That is Souparno Roy or Roi. Right. A person having an ambiguous or vague knowledge about both concepts, that is tiger or whatever it could be, has a better sense of associating them in a novel way. The tolerance of ambiguity has been studied before as a factor of a person's creative aspect. So ambiguity is great and necessary. That was my point. And instead of thinking about a tiger, we can think about a king. Excuse me, not about a king. Yes, about a king, a lion, which is the king of the animals. To make a sheep pun on these names that we will perhaps never forget after this. No, but ambiguity is great, and we need ambiguity. That's the salt of the...
Salt of the earth.
Yes.
Very good, Kalle. Thank you very much.
A break, a pause, no?
I think I will continue because there is a bit of lack of time here. Yes, Chris King is showing that ambiguity is at the very center of creation. And there are ideas that popped into my head to say that ambiguity and symmetry breaking could be relevant in understanding the Vedic concept of prana that we've taken up before. That the very force of ambiguity is the creating power, so to speak. And I will continue where I left off in the third stage, the chaotic evolution stage. And I also have to mention these are areas that has been touched before. I don't know if you remember that color, but this was William Blake and his repulsion of Newton. And then we spoke about chaotic theory as a segue into understanding quantum theory. It is it's not unfair to say that chaotic theory is occupying sort of a middle ground between absolute quantum thinking and the old classical thinking. So Konrad Lorenz and Mandelbrot opened up an area that I would say makes it easier to understand quantum theory, because in itself understanding quantum theory is definitely a quantum leap of creativity. The Wigner function, introduced by Wigner in 1932, is a probability distribution which helps to transform the trajectory of a quantum system or operator in phase space. From Hilbert space, unlike a classical system, it is not possible to measure x and p of a quantum system simultaneously. Thanks, of course, to the uncertainty principle. Hence, we resort to the Wigner function, described as, and here we have the Wigner equation, where psi is the wave function, psi star is its complex conjugate, and x and p are position and momentum variables, and h is Planck's constant. The centroid of the Wigner function is the phase space point, defined by the mean values of x and p. For this quantum system to act as a classical one. The Wigner function needs to be localized. That is, its distribution needs to be sharply peaked about the phase space variables so that its evolution can be described classically in terms of these variables. And I have to put in a note here, already described by Chris King and further developed by, for instance, Podolsky, and that is, do not confuse the formalism with truth. We need to describe quantum events classically. That doesn't make them classical. There's a very, very fine line there. The revolution of the centroid of a Wigner function over time, given in equation 48, follows the Ehrenfest equations. Now, for a highly localized Wigner function, the expectation value f as a function of x and t can be expanded about x with a Taylor expansion. Doing so and neglecting the higher terms readily makes the equation perfectly Newtonian. And there you see. I will go down to the last paragraph before the last. The mental state function psi, an essentially quantum system, also can be described using Wigner distribution, which undergoes similar evolutions. Continuous exposure to the external perturbations introduces the necessary noise which in principle gives rise to the classical and chaotic behaviors. We hypothesize that the above discussed chaotic trajectory is the reason why individual creativity is person-specific. Evolution of the mental state in this environment depends heavily upon the initial conditions and exhibits disorderedness. That's why even after going through the same two initial phases, creative process is found to be different for everyone. The nature of the stimulus, again, decides who will be a painter and who shall excel in music. Overview of the hypothesis. Here we have proposed a hypothesis that tries to explain the creative process from its inception to its evolution. This hypothesis uses quantum physics and its unusual but highly effective approach to divide the whole process into three distinct stages. In the primary or pickup stage, the mental state function operating in a Hilbert space we call mental state space. Interacts with an external stimulus denoted by an operator and begets a new state function. This change marks the start of the creative process. And here I will make a reference to the lecture 1339, where we took up Burckhart's self-regulation. It is very important that this be regulated. And this is, I would say, the left hemisphere's domain, to see to that the three different stages happen in the correct order, at the correct time extension. So there is a need for order also in this ambiguity. In the next stage, which we denote as leap stage, this state function, primary node, leaps between the conceptual nodes further. Analogous to electrons jumping from lower to higher shells. Absorbing external energy inside an atom. Ambiguity, similar to energy, very important. Ambiguity is the active agent that makes the state function leap the conceptual nodes. During the evolution, the state function continuously interacts with the external environment in the form of contexts, memories, or stimulus. These interactions keep injecting noise in the evolving Wigner distribution of the state function. Ultimately, localizing it and making it classical, and furthermore chaotic. That is, subjected to strict conditions. This constitutes the third and final stage, called the chaotic evolution stage. We propose that this final stage indicates individual creativity. That is, since here the state function evolves in a disorderly, chaotic manner. being highly sensitive to initial conditions and also, since this stage is dominated mostly by external stimulus, hence the nature of stimulus can affect the chaotic evolution heavily. This variation in interaction with stimulus is, we believe, the reason why every creative individual has a unique nature of creativity, even after going through the first two common stages. There is in the article a schemata made up. I refer here to the link in the description. The main features and advantages of the hypothesis can be summarized as one, this novel hypothesis takes into account the fact that explaining creativity using classical realm can not describe the process in its entirety. And hence a quantum physical approach needs to be introduced. Two, unlike existing ideas which are necessarily top-down, ours is bottom-up. We try to explain the starting point of the process and discuss how it can evolve into the creative effects that one observes as a final picture. Three, the effect of stimulus and its nature that is the degree of ambiguity, continuity, is given the utmost importance in this interpretation. My comment here is that see also continuity as very important. It is a continual happening. It's almost like an energy. Before I conclude, I will look once more to Boeckers and what he calls self-preservation and self-regulation as a reference to the, I would call, hard protocol suggested by Souparno Roy that needs to be followed in order for ambiguity to spring into existence. Without self-regulation, there is a symptom called mind wandering that represents the incapacity of regulating attention on a conscious basis. It is easy to demonstrate that without self-regulation training, our mind is time and again captured by and concentrated on ill-defined thoughts, stimulated by sensations and feelings which arise in activity. This lack of an adequate standard of direction and control is the first and only real difficulty which blocks the growth of self-regulation in all directions. The valuable opposite of mind wandering is therefore not concentration. For concentration represents the initial inadequate response. The capacity to command with speech orders, the inhibition of our response to these automatic thoughts glued to our sensations and emotions. Is essential to overcome what is now called attentional inertia. And which make us concentrate on salient thoughts and process. I.e., which make one think one idea at a time. Self-regulation of attention is necessary to maintain more than one idea. More than one decision and more than one rule at a time in our mind. Learning this self-regulation of attention is the only way to create valid links between different sets of concepts and to implement structured, concerted decisions. Against the force of habit and against the desire to feel right, physically and emotionally. This is at the very core of self-representation. I think there is nothing far-fetched or impractical in this connection between self-regulation and self-preservation. I would say the mind wandering is very close to the classical model, where our mind remains utterly passive to the exterior and by itself determines reality even before it happens. This is not letting presencing act its own way. Oddly enough, a result of inaccurate discipline. The 3 stages described needs to be followed rigorously. Otherwise, everything becomes automatically unambiguous, determined. So this puts in concert both the ideas of the left hemisphere standing for rules, regulation, strictness, and discipline. Repetitive and will-enforced thinking, which makes ambiguity possible. It's an active way of thinking, and it is fueled by this force. I do like the term ambiguity as prana, or energy. In the other article of Chris King, so I recommend, or go in and see 1339, he shows that this creativity, in fractality called symmetry breaking, is at the very core of creating the universe. And the reason for that there is life at all. It's a quote here from his article. Life is the ultimate cosmological consequences of the four forces of nature acting in hierarchical sequence. So the breaking is what causes everything. But order is also present. Order is necessary for the system not to become static, not to become inert. And I think this is a creativity emergence criticism of the Newtonian paradigm. It leads to, in the ground, that the world becomes an illusion constructed by a random process outside the domain of our control. A little bit, once I think of that, then I think of that, and then I think of that. That is what Newtonian paradigm does to us. This is living the Newtonian paradigm. I will read the conclusion and then we can take some thinking about it. Summary. 1. Development of knowledge about the creative process by detailing each of the steps. 2. Inflicting further investigation in this specific topic about the use of advanced physical theories. And that is quantum field theory. 3. Finding the causal relationship between ambiguity and creativity. which in turn can help promote creative aspects in young individuals. 4. In long term, encouraging democratic creativity instead of narrowing the term creativity by associating it with genius individuals. Spreading it to otherwise mundane society and system will generate productivity across every social platform. 5. Improvements in the development of the skills of creativity, critical thinking, and producing novel ideas are essential for developing the next generation of researchers. So that's my summary of the main article and the 2 reference articles. And of course, this is covering a lot of ground, and in later lectures I will go into details. But I think it's good to establish a platform that includes creation and creativity. Maybe we have some questions from my dear colleague here. Or comment.
So, what is the main takeaway from Chris King? He mentioned quantum fields. Quantum fields we have in the past compared it with nothingness. At least our friend Alan Emre, he speaks about quantum fields as something potential. Quantum fields they represent emptiness, but they are not empty in our sense. And we could say quantum fields are also something ambiguous. There's something creative. You can create something from there. And how is that what Chris King says? What would you say about quantum fields?
Yes, in all 3 articles we go back to the creative field, and the mental field, or called the Hilbert space, is a quantum field. What is a quantum field? Well, it's an area of ambiguity. Often it is called an area where nothingness and existence lie in a superposition. But we need to remember also, and this is pointed out by Souparno Roy in his excellent article, that our consciousness of course is working via the same principle. It is also very helpful when you understand it still has to be explained classically. Do not confuse the formalism with what we have underneath. And I would say this is the take from both Chris King and Bogarts. If you decide preemptively that existences are out there, both in your personal node, so to speak, and on the other side, the exogenous node, there would be pre-attempts at defining. And this is this grasping that often Ian McGilchrist, in his excellent book, The Matter with Things, points out, that left to its own doings without rules, the left hemisphere will try to grasp everything. I would say that is very similar to trying to grasp a sandcastle. You destroy it. I think it's important to understand what sort of consciousness lies behind the Newtonian paradigm, and also to recognize how we sort of go in more into one area, become more Newtonian, more determinate, more fixed and uncreative, and also, and this is from Bocatz, in that moment we also tense. Tension is always there. And I think this is a very close connection between mind and body. And Souparno is excellent in showing how a tensed mind, an unambiguous mind, a determined mind will sort of stop the energy of the quantum field, the creativity process itself. Think of a stream that's flowing. It has a flux, it has a direction, and you can see the determination, the definition as the river freezes. There will be less movement, and here also direction disappear. There will be no direction by the river. It comes to a standstill. That's tension in the mental sphere. That tension makes for a determinate, reductionist world. It's an attitude, just as Ian McGilchrist says. Before I get too enthusiastic, I think we have, I say thank you very much. Thank you for your patience, and have a very pleasant morning. Bye bye.